In this section, we're going to learn how to solve systems of nonlinear equations in two variables. Let's go ahead and jump right in, and we'll solve this system in number one using the substitution method. Really wanted to highlight that in green. So here we're going to use the substitution method. Now we're given two equations in our system. The first one, x squared plus 4y squared equals 16. And the second one is x minus y equals 4. So why don't we solve this second equation for x? And we can say x is equal to 4 plus y. So now we're going to, let's write that first equation down. And here we're going to substitute 4 plus y in for x. And now you can see we just have one variable. So here's 4 plus y, and that is our x. Okay, let's go ahead and square this binomial. We have 16 plus 8y plus y squared. And now we still have our 4y squared equals 16. Okay, and so this is equal to 4 plus y multiplied by 4 plus y. Just going to move that up a bit. I'll just leave it alone. Okay, so now let's go ahead and combine like terms. And as you can see, that brings 4y squared. And the y squared is 5y squared. And then we still have our 8y. And now we can say that's equal to 0 because we will subtract 16 from both sides. Let's go ahead and factor out a y from both terms. So we can see that y is equal to 0, or 5y plus 8 is equal to 0. And y is equal to negative 8/5. Okay. So now, if we have y equal to 0, and if y is equal to 0, we know that x is equal to 4 plus 0, and x is equal to 4. And why don't I wait on that? So if x is 4 when y is 0, we have a point 4, 0. Okay, now let's take a look. We have y is equal to a negative 8/5. So we have x equals 4 plus y. And we have x equals 4 minus 8/5. And we have x is equal to 12/5. And we have a point on our line, 12/5, negative 8/5. Keep in mind that the solution of a system in two variables must be an ordered pair, or I should say ordered pairs. So 4, 0 is a solution, and 12/5, negative 8/5 is also a solution to the system. Okay, maybe I should take those off. I'll put them back on. Okay, now let's take a look at the system here. We're given, and we're also going to use substitution here. And as you can see, we're given y is equal to root 1 minus x. So let's go ahead and write 4x squared minus y squared is equal to 4. And we'll substitute 1 minus x under a square root in for this y. So here we have 4x squared minus root 1 minus x all squared is equal to 4. So we have 4x squared minus all of 1 minus x. So be careful with your parentheses there. So we have 4x squared minus 1 plus x. I'm going to put the plus x first and then the minus 1 equals 4. Let's bring that 4 over to the left-hand side. So that would be a negative 4. So we have a negative 5. Okay, so we need to factor this. And I don't know if you have a certain way that you factor. I can go ahead and show you here. I go ahead and put that 4 here. So two numbers that are multiplied together to equal 4. Excuse me, negative 20, 4 times the negative 5. And then two numbers that add up to equal 1. And that would be a positive 5 and a negative 4. So then what I do is I divide by the leading coefficient and an x. So I'm going to divide this by 4x and this by 4x. This is finished 4x plus 5, and this can be reduced to negative 1 over x, so that's multiplied by x minus 1 equals 0. So you may have your own way to factor, but I like to factor that way. So let's go ahead and begin to plug these values in. So if we have, we need to solve this. So here either 4x plus 5 is equal to 0, or x minus 1 is equal to 0. So x is equal to a negative 5/4, or x is equal to 1. Okay, so now let's go ahead and place both of those over here. We have an x equal to a negative 5/4. So when x is equal to negative 5/4, we have a y equal to root 1 minus x. Y is equal to root 1 plus 5/4. And we have y equal to root 9/4. So the square root of 9/4, and we'll have y equal to 3/2. Okay, now we have, now we have one of our solutions, and that solution is negative 5/4, 3/2. Okay, how about when x is equal to 1? We have y equals root 1 minus x. 1 minus 1, square root of 0 is 0. So now, we have 1, 0 as another solution, or our other solution of the system. Okay, how about nonlinear systems of equations? How are we going to solve those? Well, sometimes addition might help. So let's take a look at this. In number 3, these are nonlinear. And again, remember, let's go back to number 2. These 2 points, this point and this point, that's what we found. 1, 0, and negative 5/4, 3/2. That's the solution where these intersect. Here is 4, 0, and that is 12/5, negative 8/5. So you can see the solutions here. Likewise, here they are. The solutions of this system are where these graphs intersect. Okay? So, as you can see, we're probably going to get, or we are going to get, 4 solutions here for this system. So as you can see, substitution, I guess you could solve for one of the squared variables, but if you look closely, you could multiply this second equation of the system by a -1. So actually you would have x squared plus 5y squared equals 25, and then have a negative x squared plus 4y squared equals a -16. And now we can use addition, the method of addition. So if we add these two together, of course, we have 0x squared. 9x squared equals 9. Y squared equals 1. And of course, y equals plus or minus 1. Okay, so let's go ahead and plug those in. You can plug these into either equation, either one of the equations in the system, but since we use that first one, we're now going to use this next one. So we'll have y equal to 1, and we have x squared minus 4y squared equals 16. 1 minus 4y squared equals 16. Whoops. We have x squared minus 4 equals 16. So we have x squared equals 20. So we have x equals plus or minus root 20. So x equals plus or minus 2 root 5. Okay, so with that, what do we have? That was when x was equal to 1. So we have, y was equal to 1. So we have 2 root 5, 1. And the opposite of 2 root 5, 1. Here are 2 of our solutions. So you could see those were this one and this solution, okay? So now we'll look for those other ones, okay? So now we'll have y equal to -1. And if y is equal to -1, and we're using x squared minus 4y squared equals 16. And here we get x squared minus 4 equals 16. And we're back again to x squared equals 20, x equals plus or minus root 20, and x equals plus or minus 2 root 5. So what do you notice? Yep, so we have very similar. We have 2 root 5 -1, and we have the opposite of 2 root 5 -1. So there are our other 2 solutions right there. So we have 4 solutions. Okay, let's do the same thing here, solving by addition. And as you can see, we could multiply the first equation by a -2. And let's see what we have. I'll just write it under here. We have a -2x squared is equal to a -32 plus 2y squared. And we'll add that to that second equation. So this is equation 1. This is equation 2. And now we'll have 2x squared plus 2y squared equals 8. Let's clean that up. So we have a negative 2x squared, and we'll have to subtract 2y squared equals a negative 32. And then equation 2, 2x squared plus 2y squared equals 8. And now we're going to use the addition method here. And we end up with 0 equals a negative 24. 0 equals negative 24. So here we have an inconsistent system. This is a false statement. And whenever you have a false statement, we have an inconsistent system. There is no solution. Okay, so this system can't be solved in number 4. Okay, moving on to number 5, and there's lots of ways to solve this system, but I really wanted to show you this UV substitution method. And any other substitution method might work, but here, why don't we do this? Here, we are going to let u equal 1 over x squared, and we're going to let v equal 1 over y squared. And if we do that, we will now have, and let's look closely, we will now have u minus v equals 1. And this second equation, we have 2 times u minus v equals 5. And now we're going to solve this by the addition method. Okay, so here's equation 1, here's equation 2. We're going to multiply equation 1 by 2, and let's see what we have. 2u minus 2v equals 2. Here's equation 1, here's equation 2, and of course that's 2 times equation 1. And now, if we add these together, and I probably should have multiplied by a negative 2. So this would be a negative 2, and that would be a positive, and this would be a negative. That will help me here when I use the addition method. And adding these up, you can see that I have v equals 3. So if I have v equal to 3, that's the same thing as saying 1 over y squared equals 3. So y squared equals 1/3, and y equals plus or minus root 1/3, which is equal to plus or minus root 3 over 3. And since v is equal to 3, let's go ahead and take a look at equation 1. U minus v equals 1. U minus 3 equals 1. And u is equal to 4. And I'm going to highlight these when we get these. Okay? So if u is equal to 4, that means that 1 we let u equal 1 over x squared. 1 over x squared is equal to 4. So x squared is equal to a fourth, and x equals plus or minus the square root of 1/4. So x equals plus or minus 1/2. So now we have to write these solutions, okay? So x is plus or minus 1/2. When x is root 3 over 3, or the opposite of root 3 over 3. And, whoops, I'll leave both of those positive. And then, now we'll have negative 1/2 with each of those, root 3 over 3, and the opposite of root 3 over 3. And there are our solutions. Let's end this section using nonlinear systems of equations to solve an application problem. We have a right triangle that has a hypotenuse measuring 13 inches. Okay, let me just go ahead and draw a right triangle. And the hypotenuse is 13. And the area is equal to 30 square inches. So the area of this rectangle is 30. And we want to find the length of each leg. So here we'll have, you can put them either way. I'll just put X and Y here. You could have put them the other way. So let's use the information about area first. So area is equal to 30. And we have 1/2 base times height, 1/2 x times y is equal to 30. So we have xy is equal to 60. So let's just go ahead and solve for y. You can solve for one of the variables. And y is 60 divided by x. So what could we do? So if we know y is equal to 60 divided by x, let's now use what we know. So this is known area. This is area given. And here we're going to use, whoops. Here we're going to use the Pythagorean theorem. And there we know that x squared plus y squared is equal to 13 squared. So we know that x squared plus y squared is equal to 169. So now we're going to let y equal 60 divided by x. We'll plug that in, substitute that in. So x squared plus 60 divided by x, all squared, equals 169. And that's equal to, why don't we multiply everything by x squared and clear this? That would be 3,600 divided by x squared. So why don't we multiply this entire equation by x squared? Let's see what we have. So we have x to the 4th plus 3,600 equals 169 x squared. So now we're going to set this quartic equal to 0. Okay, and so factoring this, if you need to pause and go ahead and try to factor this, go ahead, but this comes out to x squared, so you need to factor using your own method. So we have x squared minus 25 multiplied by x squared minus 144. So we know that either x squared minus 25 equals 0 or x squared minus 144 equals 0. X squared equals 25. Now we're only going to take the positive root because sides have to be positive. Sides of any figure have to be positive numbers. So x is equal to 12. Okay, so right now what we have is we're going to use these over here. So what we know is that if x is equal to 5, we know that y is equal to 60 over x. So y is equal to 60 over 5. So y is equal to 12 when x is 5. Well, when x is 12, we have y equal to 60 divided by x. Y equals 60 divided by 12. And we get y equal to 5. So what you notice is that the legs are 5 inches and 12 inches. Okay, that concludes this video.